Hello, AC students. Today, I wanted to just go over the refrigerant cycle, and this is just the changes in pressure and state that the refrigerant goes through at the different parts of the AC system. I think having a strong understanding of this cycle and what's going on and when these changes in pressure and state are happening helps you understand what's going on in the AC system, and you can better diagnose once you get there in the future. So what I want to do right now is open up my whiteboard. All right, so I like to break this up into basically a big circle. That's what a cycle is, right? It's going to transfer through a series of changes and come back and start it all over again. And that's what the refrigerant does in the AC system. It travels through these different states and pressures and goes through this cycle, and then it repeats itself and goes back and starts over again. So if we think about it in a circle, you could also divide that circle into kind of 4 sections almost. And if each one of these sections, we're going to have a different, we're going to have a change at each one of these intersections here where this cycle crosses over here. So if we wanted to break this up, we could put the different parts of the AC system and what they do and how they affect the refrigerant. So over here, I'm going to put our compressor, and then it travels down here through our AC system from the compressor down to our condenser, and then over to our expansion valve, or orifice tube, depending on what type of system we have. And then it's going to go from there into our So those are the major players in our AC system. Now, depending on if we have an expansion valve or an orifice tube, we'll have different we will have different components. If we have the orifice tube, then you're going to see over here between the evaporator and the compressor, you're going to have a accumulator. If we have an expansion valve, over here after the condenser, we're going to have a receiver dryer. But we won't put these in for this, just for this talk. We're just talking about the refrigerant cycles. So we don't need to talk about those in this context. But so let's start over here at the beginning where I started, the compressor. Just like its name says, it's a compressor. Just like an air compressor we have in the shop, it increases pressure. So if we know what a compressor does, then we know going in is going to be low pressure. Coming out should be high pressure. Now, we should also know that you can, from our hydraulics lessons and things that we know, you cannot compress a liquid. If a liquid makes it into a compressor, then that spells bad news for the compressor. The compressor can end up seizing up and sustaining damage, just like if you hydrolock an engine, right? If water makes it into the cylinder, you cannot compress the water, you bend a rod. So same thing here. You cannot compress a liquid. So we have a low pressure. Let's get over here. We got a gas going in. We should have a gas coming out. So we have a change in pressure right here. The state of the refrigerant stays the same. It's still a gas. But then if we come down here, we have another component and we have another line. So we have a change of some sort. And in our condenser, again, just like the name implies, we're condensing something. Just like if you have a cold beverage on a hot day, sometimes you'll get the water on the outside of your glass or your container. That's because the moisture in the air is condensing. And what it's doing is it's going from the gaseous state down into a liquid state. So down here we have a change in state. So we're going from a gas on this side to a liquid. But we did not change pressure, so we're still high pressure. So our high pressure liquid is going to travel from our condenser over to our expansion valve or our orifice tube, depending on what system we have. And then again, now here, we're not going to change state, right? We're going to change pressure. So here we have another intersection. So we're going to change from a high pressure liquid to a low pressure liquid. All right. So then if we have a low pressure liquid leaving our expansion valve or our orifice tube, going into the evaporator, now we've reached another intersection here. So we got another change. So just like at the bottom, we change states. That's what we're going to do up here as well. We're going to go from our low pressure liquid over to a low pressure gas, in which it goes back to our compressor and we start the whole process over again. But now let's think about these transitions and what's going on. So if we have a low pressure gas being turned into a high pressure gas, we're increasing the pressure on that gas. Well, what happens when you increase the pressure on something or you compress something? You're going to end up adding heat to it, right? So it's going to get hotter. But also, in the case of refrigerant, and just like any other liquid, you also can increase the boiling point of that substance. Just like the coolant and the water in our engine cooling system. That system is under pressure and it increases the boiling point. So just like if you open the radiator cap while the system is hot, that water and coolant inside there can flash boil and it can end up scalding you, but it boils out of the radiator then. So we've increased the pressure, we've increased the temperature going into the of the refrigerant here. So we've raised the boiling point. So now we run it through the condenser and that causes it to go back down into a high pressure liquid, right? So now we have a liquid going into our expansion valve or our orifice tube. The orifice tube and the expansion valve, they do the same job, but in just slightly different ways. But what they are doing is decreasing that pressure. They're decreasing that pressure rapidly. So just like with our coolant, what happens when we take the coolant, the radiator cap off, and the system all of a sudden is no longer under the pressure, that boiling point drops rapidly and it flash boils. Well, that's exactly what we're doing with our refrigerant here. We allow it to go through a metered orifice or an opening, right? If we have an expansion valve. And as soon as it gets on that other side of that orifice or that valve, the pressure is released. Just like when you stick your thumb over the end of the hose, right? If you stick your thumb over the hose, you're increasing the pressure behind your thumb in the hose. So you're upping the water pressure. Well, once it gets past your thumb, the pressure is no longer there and it shoots out. Well, that's just like what we're doing with our refrigerant here. That high pressure liquid refrigerant is just like the water in the hose on your thumb. All of a sudden it gets past that restriction, the pressure drops, and it's allowed to lower that boiling point rapidly. So now our refrigerant starts to boil. And as it boils, it's transitioning from that liquid into a gas. And when it does that, it is absorbing as much of the heat in the area around it as it can. So just like a pot on the stove, right? If you put a pot of water on the stove and you turn the burner on high, that water is absorbing the heat from the stove, from the flame of the burner. And it's storing that heat, and it's taking that heat, and it's turning into, it starts to boil, and it's turning into a liquid. So just like the steam rising off of the water on the stove, the refrigerant is absorbing the heat in the passenger compartment, and it starts to boil off and turn into steam and travel through the evaporator. It's evaporating, again, just like the name implies, and it travels through the evaporator and back to the compressor. So it's taking the heat from the passenger compartment and transferring it back around to the condenser, where it can release it out into the atmosphere and turn back into a liquid. So what we're doing with the AC system is we're playing with the states of matter and the pressures of the refrigerant to absorb the heat in the passenger compartment, and then to allow it to be given off at the condenser at the front of the car. So if you think about these components and how they look, a condenser and evaporator both resemble kind of a radiator, right? We have the fins and we have air being able to travel through it. Well, that's what we're doing. We're exchanging heat. At the evaporator, the blower fan will blow the air across the evaporator, and the evaporator, again, while that refrigerant is starting to boil, just sucks all the heat out of that air it can, which cools the passenger compartment. It also removes all the humidity out of the air, because that air starts to condense on the outside of the evaporator, and it leaks out through the bottom of the car. You know, and sometimes on humid days when you run the AC, you can look and a pool of water will generate under the car. Well, that's the humidity in the air as it blows across that evaporator and it hits that cool surface of the evaporator. The water condenses and it's allowed to drain out the bottom. So we have dehumidified and cooled air blowing out of the vents into the passenger compartment, and all that heat that we absorbed in the evaporator is going to be transferred out to the condenser, where it can be given off into the atmosphere. So this cycle that we just went over here is one of the main, is the core of the air conditioning system. These transitions from gas, from a low pressure gas to a high pressure gas, and into a high pressure liquid, back into a low pressure liquid, and then back to a low pressure gas. That cycle is air conditioning. That is what it is. So this basic cycle here, this diagram that I just drew in one of my first classes, we dubbed it the Wheel of Death, is very important for you to understand, and to understand what's going on in each of the components of the AC system. These different components make up the AC system, and just by looking here at this diagram, simple diagram, being able to know what's going on, you know exactly what each component's doing and how it affects the refrigerant. So this is the basic understandings of the air conditioning system. So go over this. I want you to be able to know this diagram, be able to draw this diagram from memory. It's a hint, you may end up doing that in a quiz maybe, or some form or another. So go ahead and pause the video, write this down, get draw your own version of it, and study it. So hopefully that explains a little bit of the basics of AC, and I'll see you later. Thank you.